Balance the following chemical equations and classify them as either combination, decomposition, single replacement, or double replacement. We do get into a pattern sometimes with balancing reactions where we expect only very small coefficients, 2s and 3s and 4s, as what would be necessary to balance it. That's not true. Generally we want whole numbers, but they don't necessarily have to be always small numbers. This first problem will point that out. If I look at this problem, I have 8 sulfurs on one side and only 1 on the other. So to get my sulfurs to balance, I need to put an 8 in front of the sulfur hexafluoride. But if I'm looking at this, I now have 6 times 8, or 48 fluorines on the product side. I only have 2 on the reactant side. So to make the 2 into 48, I need to multiply it by 24. Again, not exactly small coefficients, but what is required to balance the problem. We have 2 pure elements reacting to form a compound. This is a combination reaction. In the next problem, we have potassium chlorate reacting to form potassium chloride, often used as no salt for people that have high blood pressure, and oxygen gas. So if we look, we have 1 potassium on each side. That's balanced. We have 1 chlorine on each side, also balanced. And we have 3 oxygens and 2 oxygens. This is one of those cases where you do need to check the oxygens. They're not always automatically balanced by the time you get to the end of the problem. So we can find the least common multiple though. If we have 3 and 2, the least common multiple would be 6. But that messes up my potassium and my chlorine, so I need to put a 2 in front of the potassium chloride to get everything to balance. Here we have a single element reacting to form 2 or more simpler elements or simpler compounds or pure elements. This would be a decomposition reaction. Next is a really fun reaction. Used to be used quite a bit in the railroad industry to weld together ties. They have better, more effective ways of welding now, but this was a way that they could take with them without electricity or anything else to do temporary repairs. It's called the thermite reaction, and we take aluminum and we react it with rust. 2 fairly common chemicals to run across. It makes aluminum oxide, and it gets hot enough to make the iron molten. So if we look at balancing it, we have 1 aluminum on the reactant side and 2 on the products. So we need to add a 2 in front of the aluminum. 2 irons on the reactants, only 1 on the products. So we need to add a 2 in front of the iron, and the oxygens of 3 and 3 are already balanced. This problem, where we take 1 pure element and a compound and react them to form a different compound and a different pure element, is a single replacement reaction. Lastly, we take aluminum permanganate and sodium fluoride and react them to form sodium permanganate and aluminum fluoride. If we look at our aluminums, we have 1 on each side. If we look at our manganese, we have 3 on one side, but only 1 on the other. So if I add a 3 out in front, that'll actually balance my manganese. Skipping oxygen for now, I have 1 sodium, but now I have 3 sodiums with that coefficient. So I need to add a 3, 3 fluorines, 3 fluorines. Lastly, I check my oxygens. I have 12 oxygens on the reactant side, and I have 12 oxygens on the product side. This would now be balanced. 2 compounds reacting to form 2 different compounds would be a double replacement reaction.